Thanks for tuning in. I'm going to show you how to make this reaction timer game, which is it's a nice little project to make, lots of fun. So here's the schematic and a quick demo of how it works. We changed the delay of our reaction timer using a potentiometer and a switch to turn on pairs of LEDs. It's very simple to do, and I'll take you through how to do it now. So we've got 13 LEDs. Pin 2 is the one on the left up until pin 14, which is the LED on the right, also known as A0, but I always label them as numbers. Pin 16 is our switch to turn the LEDs on, and there's a little button LED indicator just to show when the button is pressed, but you don't have to have that on. Pin 19 is the potentiometer, which we will take an analog reading from. The first thing to do is to get a row of LEDs turning on and off. As soon as we turn the Arduino on, we've got a for loop going in the background between 2 and 14. And then as soon as we press the switch, we digital write the LEDs on and off with a small delay. And whatever the number in the for loop is the pin of the LED that we turn on. So when we let go of the switch, the for loop continues, but it doesn't affect our LEDs. We can change the delay with the potentiometer, and that'll give us a number between 0 and 1023, which we can use in milliseconds as our delay between turning the LEDs on and off again. Lighting a row of LEDs. So we'll set up a for loop to automate the LEDs going on and off with a little delay in between. So we're going to have a for, then declare an integer. I'm going to call it LED A, and that's going to start at the number 2. And it's going to end the for loop when it reaches the number 14. And then we increment by 1 each time. And whatever's inside the curly brackets, that's what will be done every time the for loop increments by 1. So we're going to digital write LED A high. Then we're going to delay and then digital write LED A low again. It does everything inside the for loop in its entirety before it increments to the next number in the loop. But how much delay? Well, let's make it variable. We'll call it del. So we need to declare an integer called del early on in the program. So let's write this code in the Arduino IDE. I'm going to declare an integer called LED A, so I don't have to declare it inside the for loop. And we need to set all our pins as inputs or outputs, and we've got 13 of them. So the slow way would be to copy and paste, make all the LEDs outputs and change the pin number. But when you've got multiple pins to do anything with, you should use a for loop. It's really a lot quicker. So this is another for loop just to do the pin modes. For integer, which you can call it anything, I'll call it X. For it's equal to 2, semicolon, up until 14. So you can either say less than 15 or less than or equal to 14. Add 1 to X. And then do the pin mode, bracket, X, comma, output. So that'll make 2 an output, then 3 an output, all the way up to 14. Don't forget your curly brackets around your for loop. I'm going to do an integer for the switch, the button switch, which is connected to pin 16. I always use the numbers of pins rather than the letters. It's easier to manipulate them later if you need to. Do a pin mode for the switch. It's going to be an input from the Arduino's point of view. And that's the end of our setup for now. So the code for LED A is 2 up to 14. do some stuff. So for LED A equals 2, semicolon, LED A is less than 15 or less than or equal to 14, add 1 to LED A. You need a Mario moustache and a Luigi moustache for your for loop. Digital write, LED A high, semicolon, then delay a little bit, then write it low again. I'm going to do a delay called del, so we need to declare our integer del and give it a nominal value of 100, which will be 100 milliseconds. Then digital write, that same LED, low. And once it's done everything in the for loop, it'll exit and re-enter and increment the number to 2, etc. Paste your code into Tinkercad, and as soon as we start it, it's doing what we asked, because we haven't done anything with the switch yet, so that's a good start. If you want to see any variables changing, then you can do serial begin in the setup, and then within the code do the serial print ln for a new line of your variable. I'm going to look at LED A and see what its value is. So we'll start that off, and you can see LED A is incrementing with a delay of 100 milliseconds. We can slow it down if you want. So we've got one row of LEDs lighting up, and that's good, we're getting there. Controlling LEDs with a button switch. So the button switch goes into pin 16. It's pulled low by a 10k resistor, and we can pull it high by connecting the left and right sides of the switch when we press it. So we need to declare a value for the digital read of the switch. So SWVal, switch val. Then we'll do an if. But first we need to read the state of that switch. Is it high or low? And if the switch is high, as in connected to 5 volts, switch val will be high. And in that case, do what's in these curly brackets, but be careful where you put your brackets. So the if begins there and it ends there. But there's also our for loop exterior to that. So keep a note of your open and closed Mario and Luigi moustaches. I want a serial print LED A, again just to check its value. It's going really fast outside of the switch being pressed because there's no delay. But as soon as we press the switch, we enter the part of the code that has a delay, and it digital writes the LED high, waits a bit, then turns it off again. So that's working good. Lighting opposite LEDs. So we want to light up pairs of LEDs. So instead of lighting up just the one, we're going to light up its complement, the one on the opposite side. I'll call that LED B. But how do we figure out what it is? Well, when LED A is equal to 2, we want LED B to be 14, the opposite LED, and vice versa. So 2 and 14 are related by the number 16. So LED B is going to be 16 take away LED A. So 16 take away 2 gives us 14, up until 16 take away 14 gives us 2. So instead of writing just LED A high and low, we're going to do LED B high and low as well. Press the switch, and they both turn on, and that's great. The problem is they turn off when we let go of the switch, so the game wouldn't be very good like that. Keeping opposite LEDs lit when the switch is released. So the for loop of LED A is always running in the background, so LED B is changing. When we let go of the switch, we want to make sure that the last two LEDs stay lit. So we're going to have LED X equals LED A's value and LED Y equals LED B's value. And we need to declare them as integers. So this else is when the switch is let go. So if the switch isn't pressed, light up LED X and LED Y, which are the last two values of LED A and LED B. Then turn them off again, and the on and off will happen so fast it looks like they're staying on. But you usually need a small delay, like 2 milliseconds, so that they're bright enough. Press the switch, they're turning on in pairs, and when we let go of the switch, they stay on, because we've transferred the values of LED A and B to LED X and Y. Then the last thing to do is vary the delay with an analog read of the pot, the variable resistor. That's connected to pin 19. So we need to declare an integer of, I'm going to call it pot, equals 19. Then do the pin mode of that shortly, and we need an integer called pot val, which is the analog read value. So pin mode pot is an input. Then we'll say pot value is the analog read of pin 19. And that'll give us 0 up until 1023. We're going to make that the delay. And say delay is equal to the pot value, but the numbers it's going to give us aren't suitable. We need to change them. So let's have a look at pot val in serial print. We start the simulation. It's going to go from 0 milliseconds delay up until 1023 milliseconds delay, which is too short and too fast. We need to tweak our delay a little bit. So we're going to say delay is 1/10 of delay. So that'll go to a maximum of 102.3, which is 102 milliseconds as an integer. Now we're going to print the delay, goes from 0 to 102, but a 0 millisecond delay still isn't very good, so we need to add a minimum delay. It's okay when it's 1/10 of a second, but when it's 0, you can't tell which LED is on. They're so fast. So we're going to add 40 to the minimum value of our delay. So it's going to go from 102 plus 40 to 0 plus 40, which are reasonable numbers, and you can tweak these. So here delay is at 102 plus 40 down to 40. And basically we're finished. So I hope this has been useful. Get it made and have some fun with it. And thanks so much for watching.